right, this is a quick overview of capabilities that are built into Azure that allow customers to protect themselves against ransomware attacks. And what that means is that if you're an unfortunate target of a ransomware attack and they are able to take control of your on-premises Active Directory by using cryptographic technology or CryptoLocker attack, it allows you to recover your domain controllers and other servers that you choose to protect very effectively and quickly, and it's a very inexpensive and easy way to get these services up and running to protect you using a couple of features that are built into Azure. The first one I want to discuss is called Azure Backup, and I have the link to the documentation on where you can find the detailed articles on how to set it up and how it'll help you prevent against attacks. And I'm going to walk through a really short screen-by-screen show for those who want to see how it is done, how this allows you to protect yourself. So many public sector customers already have domain controllers because they're using Office 365 and they may have set up ADFS servers with domain controllers so they can have single sign-on into Office 365. And in that case, you may already have domain controllers running in Azure where you can very easily set up Azure Backup to back up your domain controllers and frankly, any other servers that you have running in Azure and turn on some advanced security features to protect yourself against these type of crypto attacks. And what it is it's built-in additional features that do not allow administrative accounts to go back and remove things or change certain settings within the Azure Backup software that would be a typical attack pattern for a crypto attack, where first things they do is find your backups and delete them, and then they encrypt your running production systems, and then you're left stuck. And I'm sure you've read plenty of news articles about how bad that can be and how long it can take to recover from. So very quickly, the first thing that you do in your Azure tenant is you create an Azure Recovery Services Vault. This is the storage location where the backups of the different virtual machines will be stored. And there's a special security settings blade there at the bottom middle of the page that allows you to turn on this highly effective security feature that prevents these types of attacks by stopping a person from altering, changing, and or deleting your actual backup data. These features force a certain retention policy to make sure that there's adequate time to recover things, and they disable certain features like a hacker turning off your security alerts or turning off the number of restore points that you have in your backups that would prevent your backups from being effective. So once you do turn this on, you cannot turn it off, and think of that, that's by design. Otherwise, a hacker could go turn it off. So once you turn it on, it's irreversible, and these particular policies will be enforced. If you do need to edit policies, there is a setting that allows you to set up a special PIN, and of course, it's always recommended to have multi-factor authentication, and it will alert everybody in the appropriate email distribution group that somebody's making changes to your backup software. From the documentation, the retention policy that will be enforced is if you're using daily backups, a minimum of 7, a weekly, a minimum of 4, monthly, a minimum of 3, and at least 1 yearly if you're using that. And these things are more of an art than a science. We talk about recovery point objectives. For most customers, a typical scenario would be to store your weekly backups in this manner at a minimum. And there'll be other examples as well as we go through the story. You select the virtual machine. In this case, I have an example domain controller right next to my Azure Active Directory Connect server that's running in Azure. I select it and I assign the backup policy to it. And then you can see that it's been running for a period of time, and I have several iterations of snapshots as well as full backups in the vault that I can recover from, going back as far as I have chosen to set the retention policy. So in this demo environment where I took the screenshots from, my oldest restore point was set for September 12th, and if I had a 90-day policy on this, it could have gone as far back as that before I would be able to remove or delete these backups from the vault. Now, restoring to a separate network in the event of a CryptoLocker attack is also very easy, and it's perhaps one of the biggest benefits. I can just create a new virtual machine, install it into a new private network. I can restore my domain controller that I think is the most appropriate restore point, whether that's, I believe the attack happened 30 days ago or 45 days ago. I can actually restore 2 different ones, and I can compare the difference between the 2 so I can try to find out what changed, which account may have been compromised, and how an attacker obtained elevated credentials into my Active Directory forest. And this is the first step in conducting forensics to excise any compromised accounts that may have existed in your Active Directory. Once you have that right, then you go through the normal process of rebuilding an Active Directory forest. You have your FSMA roles, which are the flexible single master that allows you to create additional Active Directory sites. And from that point, I can rebuild my domain controllers on premises and connect them into this newly restored one that I set up in Azure. So that's a very brief overview of how quickly and easy this can be set up for you if you already have domain controllers running in Azure using Azure Backup. And it applies equally well to any other servers that you have running in Azure. So now I'm going to move on to the second type of defense, which is immutable blob storage. Now this requires a little bit more of an explanation into why and how that you would want to use it. So Azure Blob Storage is really just a massive amount of disk space that's extremely inexpensive that you can procure within Azure. You create what's called a storage account. You create containers underneath that storage account and you give them names, and you're allowed to, from that point forward, drop objects into storage. And the best example of an object in this scenario is an actual copy of a backup file that I may have taken on premises. So in my environment, I may be using backup software such as Veritas or Commvault or Veeam, it doesn't matter who, and I'm writing these to a file system somewhere. So I have my own backup software and I can recover files and recover entire servers if need be. Well, using immutable storage, I can take a copy of that backup and I can put it into Azure Blob containers, and I could use the flags built into the platform to turn it into a worm drive, which worm stands for write once, read many, which essentially means that it's immutable and can't be changed. So even in the event that an attacker took control of my on-premises environment, found my backup servers, found my backup files, and either deleted them or encrypted them, I would still have this immutable storage container up in Azure where I could recover the most recent backup that I wanted to use for a restore process, or the most appropriate backup based upon the length of the attack or the duration of the attack. And once again, go through the recovery process in a very similar manner to what I outlined using Azure Backup. So here are screenshots of how to set that up. This is a storage account, and I create a new blob container and I give it a name. Then I create additional containers and I put an access policy on them. And in this example, selecting the access policy, I choose immutable blob storage with time-based retention, and I can set the number of days that I want that to be set for. So in this screenshot, I only have it at 3 days where I'm doing a lot of testing and making sure things work the way they want. But in the real world, you would set that interval to be much longer for how long you want to keep your data and have it be immutable. And then I lock it after I've created it, and this effectively prevents any changes from happening to the policy itself. And I have immutable storage from that point forward for the duration, and any objects that I put into that file into that container from that point forward inherit the amount of time that's associated with that policy. And I'm asked to confirm this and say, hey, do you really want to do this? And the reason for this confirmation is somewhat self-obvious, in that once I start putting data in here, if it's a confirmed and locked retention policy, I have no ability to go back and make changes to it, and that's by design. Therefore, if I put big stuff in there and I put a super long retention policy on it, I have no way to get rid of things that I don't really want anymore. So the setup of this requires a little bit of planning, and that's an important consideration. But once I have it, if I tried to delete something out of the container itself, or the storage account, you're going to get a failure even if you're an administrator, because that policy is immediately put into effect as soon as I created it. And any files that were already in it, or any subsequent files that were put into it, inherit that policy and the time duration that is associated with it. So this brings us to the discussion on how you would want to consider using this. So a 90-day policy makes a lot of sense to me, because if you have a lurked attacker in your environment for greater than 90 days, that would be probably extraordinary. But if you have more comfort and you want to keep a longer retention policy, that's fine. You can go to 180 days or a full year. But these recovery point objectives are usually different from regular backups, where you might want to do just a single item recovery. So in this example, I'm saying create a storage account with a 90-day retention policy on each of your containers, and place a copy of your weekly backup files in those containers. And then you can age them out appropriately. You can add domain controllers, file servers, database servers, application servers. Almost any kind of data type from a backup file could be dropped in there and allow you to protect more things than just domain controllers. And then as the container ages, and once it's reached a date and time that you would no longer consider it useful for being restored, you can go ahead and delete those objects, but the delete operation, of course, will fail until you've passed the end date of the last object that was placed in the container. So if it's a day before the policy expires and I drop a new backup in there, it's still going to protect that container for another 90 days if that's what the 90-day retention policy was. And as mentioned earlier, we can adjust this for longer if there's discomfort in a 90-day policy. Now, this type of storage is used for many scenarios. Many of our backup vendors have direct integration with Azure storage in the back end. And so an example here is Commvault. They'll help you configure within their console the warm storage mode in their cloud storage, and it'll actually allow you to use the Commvault backup console to continue to do all the backups that you want and just target an Azure storage account and take advantage of the Immutable storage feature within Azure. There are other vendors that do this as well. I'm just using this one as an example, and there's specific documentation on how to set this up and that it supports all those different storage types within Azure. So having said that, I want to take a minute and break into a quick demonstration on how you might go about using this. So inside Azure, this is an example of an Azure tenant in US government Azure, and these are all resource groups, and a resource group is just a role-based access control boundary where I can go create things. So I have created resource groups, and inside them are a storage account, and inside this storage account are the containers that we talked about. And I can apply different retention policies on each of these containers. So if we're back to the 90-day policy, test could be 1 quarter, test 2 could be another quarter, and test 3 could be another quarter, and each of them would have a separate retention policy. So I'm going to run a script here very quickly, and it's going to show you how to create a new one. I'm just going to increment these numbers for people who like to go a little bit more technical and want to understand how this works. So this is a PowerShell script, and all it's doing is it's creating a new storage account and giving it a name, and then it's applying a really quick policy to it down here. And I have the immutability period set for one container to just 2 days, and the immutable period set for the second container to 3 days. And of course, I can easily change that, but this is just for testing purposes. And then I upload a couple of small files within the script just to prove that it works. So I'm going to go ahead and save this, and then go to the console and go ahead and say run it. And once I've authenticated, there are a couple of breakpoints in the script so I can validate the settings and make sure I'm happy with them. These could be removed if you wanted it to run faster. It's just creating the things that I put in the script, setting up the storage account. You can see it's named Crypto Defense 16 in the bottom terminal window. And yes, it does take a couple of seconds for it to create the storage account. And then it moves on to create the storage context in the containers and apply the policy. And now the script is complete. So if I put this down and look at it, I go back into the resource group view and I refresh this, we can see the new container. can see the new storage account. We can see the new items. And if I come over here and show you the access policy, you can see that it's set to a time-based retention of 2 days and it's locked. And you can see the second one that actually has data copied up into it. Oops. Also has an access policy and it's set to unlocked. So I'll come over here and explicitly lock it and say yes. Now I have a locked retention policy on that container as well for 3 days. So if any point in the future I copy files in there, they will inherit that policy and will be good for 3 days from the time that I drop anything new into that container. Now you may be asking, is this a manual process or can I automate this? And you most definitely can. So this is a different kind of PowerShell script. And this is intended to be run on premises or on an actual server that could go to the location where you store your backup files. So in my case, I have some example files stored in a folder here on my local hard drive. This script could actually be running locally in your own data center, and it could use the AZ copy command to push things directly into the Blob storage account. So I'm going to create a container for it. It's a new container. I'm going to call it test03. And it's created. And I'm going to come and set the policy on it one more time so you can see what that looks like if you want to do all of this manually and not script anything. I'm going to choose a time-based retention policy. I'm going to set it for 3 days. And I'm going to say OK. And then I'm going to lock it. Say yes. Now the policy cannot be changed, and any data that I put into there is going to inherit that policy. So now if I go back to my script, I see that I'm pointing at the correct storage account, I'm pointing at the correct container. I have to do something with this particular string here at the end that's called a SAS token, which is a shared access signature. So this for the very technical parts. This is how I'm allowed to connect to this storage account and actually not get prompted for an interactive login, which allows me to fully automate this and not have to sit at the keyboard and type in credentials. So this stored access signature allows me to grant all kinds of different permissions. So if I was setting this up for a 90-day policy in a particular storage account, I would pick 90 days worth of stuff. But for the purposes of this demonstration, this token is only going to be good for 8 hours. So just today, I'm going to say go ahead and generate it. This is the token itself. It's a really gnarly looking string that starts with this question mark SV. I'm going to copy that into my clipboard. I'm going to put it into my session, starting right here. I'm going to paste it in there. And now this copy command will not prompt me for credentials. It'll take the files that are on my local hard drive and it will push them up into this newly created storage group in this newly created container named test03. So let me save this file and then go ahead and run it. And you will see that it created a log file and it copied 2 files directly in. Since they were small files, it ran really fast. Now if I go back into my group, there's my storage account. Here's my container test03, and here's my 2 files that I put in there. We will go ahead and download one, take a look at it, and you can see that we have a seal, one of our customers. And that concludes the demonstration part. And I just want to point out how simple and easy that was to set up and do manually. So you could, in very, very short number of days, have complete CryptoLocker defense protection against your domain controllers and other backups just by creating a storage account, marking it and saving it with a immutable policy. It becomes a worm drive at that point. Any files that I put in there inherit that policy. And even though I'm an administrator, I cannot delete these files no matter how hard I try. If I try to delete them, even though I'm an admin, I get the deletion failed to delete the blob. This operation is not permitted because it's immutable due to a policy. If I come up a layer and try to delete the entire container, it won't let me do that either, because it said the container is protected. And if I tried to delete the entire storage account, the same thing would happen. You get a failure. And that concludes the demonstration for today. Failed to delete.